Good evening, ma'am.
Good evening, sir.
Is my audio clear, ma'am?
Yes, sir. It's clear, sir.
Okay, ma'am. Thank you so much.
Sir, you can start, sir.
Okay, ma'am. Thank you so much. Can you please make me the host of this meeting, ma'am? Okay, ma'am. Thank you so much. Good evening, students. We have already discussed the concepts related to current electricity in our previous classes. In this class, we will be discussing some numerical problems on current electricity. Okay. So for that, I will be opening a whiteboard with you. So let us start discussing some of the numerical problems on current electricity. Now I will be writing the first question on current electricity here. Three resistors having resistances R1, R2 and R3. Okay, R1, R2 and R3 are connected as shown in the given circuit. The ratio I3 bar I1, I3 divided by I1. The ratio I3 divided by I1 of currents in terms of resistances used in the circuit. Yes. Three resistors having resistances R1, R2 and R3 connected as shown in the given circuit. The ratio I3 by I1 of currents in terms of resistances used in the circuit is. Okay. So now I will be drawing the circuit. So here you have the resistance R1, and you are having the current I1 here. Okay. So this point is actually A, okay. This point is A, and here you are having R2, and here you are having R3, okay. This is R2, this is R3, and the current through the resistances is, this is I2, and this is I3. This is the another point B, okay. So this is the question, and I will be writing the options here. Option A is R1 by R2 plus R3. Option B is R2 by R2 plus R3. Option C is R1 by R1 plus R2. And option D is R2 divided by R1 plus R3. This is the question, and this is the circuit. You have to find out the ratio I3 by I1. Okay, I3 by I1 you need to find out. So of course, so this is I3 by I1. Let me write it again here. So the ratio of I3 by I1 you need to find out. Okay, this is the question, and let us see how we are going to solve this question. So you can see in the given circuit diagram, you have two branches for the current to pass here. I1 is the total current entering this circuit, and the I1 current actually gets branched into I2 and I3. Okay, so the total current I1 is nothing but the sum of the two currents I2 and I3. So first of all, you need to write I1 equal to I2 plus I3. So here you have these two resistances are connected in parallel. Okay, these two resistances are connected in parallel, which means the potential difference across these two resistances is same. In a parallel combination of resistances, you will be having the potential difference as the same. Okay, so the potential difference you know very well, V equal to I into R. So here across this branch, B is equal to I2 into R2. So I2 into R2 equal to I3 into R3. Okay. So across these two branches, the potential difference is same. So I2 R2 equal to I3 into R3. And when you need I2 is nothing but I3 R3 divided by R2. This is I2. And what you can do is you can substitute this value of I2 back into this equation. Okay. So this I1 can be written as, so let me write that here, I1 is equal to I2 plus I3, that is nothing but I3 R3 by R2 plus I3, and when you divide the whole equation by I3, you will be getting R3 by R2 plus 1. Okay, when you divide the entire equation by I3, on the left hand side also you have to divide it by I3, so I1 divided by I3 equal to R3 by R2 plus 1. Okay, now you can take the LCM. So here I can write it again. Okay, I1 by I3. So this is I1 divided by I3. So this implies I1 by I3 is equal to, taking LCM, R3 plus R2 divided by R2. Okay. So in the question they have asked you to find out the ratio I3 by I1. In that case, what you have to do, you have to take the reciprocal of this. Okay, I1 by I3. So here you have I1 by I3. You can take the reciprocal, and that will be I3 by I1. Okay, I3 by I1 is equal to R2 divided by R2 plus R2. Okay. So you have got the answer now. I3 by I1 equal to R2 by R2 plus R3. So that is actually option B actually. Okay. So this is option B. So option B is the right answer here. Okay. Do you all understand the solution for this problem, students? Anyone have any doubt here in this problem?
No doubt, sir.
Yeah. Thank you. So this is how you need to solve this numerical problem. Okay. So then we shall move on to our next problem. Okay. For that, I will be opening a new page. I will be writing the question here. In the circuits shown below, the readings of voltmeters and ammeters will be. Voltmeters and ammeters will be. Okay. So they have given two circuits here. I will be drawing that circuits now. So this is the first circuit. This is the first circuit, and you have a 10 ohm resistor here. And this is voltmeter V1, and this is ammeter A1. Okay. So this battery is providing a potential of 10 volt, and here you have current I1 flowing through this circuit. Okay, this is the first circuit, and the second circuit I will be drawing here. And here I am having one resistance also in parallel. Okay, so here there is an ammeter also. So this is 10 volt. This is 10 volt, and here you are having one 10 ohm resistor, and here also you are having one 10 ohm resistor, and this is V1. This is actually V2 voltmeter. Okay, this is V2. Okay, this is V2. It is connected like this, and this is A2. Okay, and here you are having I2 as the current flowing, and I think I can mention V2 and I2 below this voltmeter so that it will be clear. So V2, this is A2. Okay, here you are having two resistances, 10 ohm, 10 ohm, and voltmeter here, ammeter here, and a 10 volt supply here. So what are the options now? Let us see. Option A, V1 equal to V2, and I1 greater than I2. Option B, V1 equal to V2, and I1 equal to I2. Option C, V2 greater than V1, and I1 greater than I2. The option D is V2 greater than V1, and I1 equal to I2. Okay, these are the options. I think the question is clear to you. Okay. Can you understand the question? In the circuit shown below, the readings of voltmeters and ammeters will be. Okay. Here you have the voltmeter V1 and ammeter A1. Here you have the voltmeter V2 and ammeter A2. What is the readings? What are the readings of voltmeters and ammeters? They have asked you. That means they have asked you to calculate the potential difference across this 10 ohm. That will give you the reading of V1 and the total current I1 flowing through the circuit. It will give you A1. Okay, like that you have to find out. Okay, and you have to find out the relation between the two potential differences and also the relation between the two currents. This is how you need to do. Okay, and here how we are going to proceed with this numerical problem. So let us start first. Here you see this is an voltmeter, right? So what is the resistance of an ideal voltmeter? Can anyone tell me what is the resistance of an ideal voltmeter? This is a voltmeter here connected in parallel with 10 ohm resistor. What is the resistance of an ideal voltmeter? It should be infinite actually. Okay. So for this ideal voltmeter, the resistance should be infinite. Okay. For an ideal ammeter, the resistance should be 0. For an ideal ammeter, the resistance should be 0. So in this case, when the resistance of this voltmeter is infinite, there won't be any current flowing through this branch. Okay. So you have to find out I1 based on Ohm's law. Okay, based on Ohm's law, you need to find out I1. So now I will be working with the first circuit. Okay, now I will be working with the first circuit. For the first circuit, I need to find out I1. So for that, I am using Ohm's law. So R into I is equal to V according to Ohm's law. Here the resistance is 10 ohm and the current is I1. Okay, that is equal to voltage. Voltage given here is 10 volt. Okay, voltage given here is 10 volt. So that 10 volt I will get here. That means I1 equal to 1 ampere. Okay, I1 equal to 1 ampere. That is the reading of this A1. Okay, and based on this, I can find out the value of this V1. V1 equal to I1 into R. So V1 is equal to I1 into R. That means I1 is 1 ampere. 1 into resistance is 10. So that will give you 10 volt. Okay. So V1 equal to 10 volt and I1 equal to 1 ampere. So this is the first circuit. This circuit. Okay. And now I am going to work with the second circuit here. For the second circuit, here you have added a 10 volt to this voltmeter V2, but will the current flow through this network? Can anyone tell students? Will the current flow through this network? Can anyone tell me? Through this branch, will the current flow or not? Through this branch, will the current flow or not?
Sir, they are not flows, sir.
Yes, your answer is right. Can you explain the reason behind this? Your answer is absolutely right. Okay. Can you explain the reason behind this?
Sir, they are 10 ohm resistance and voltmeter will be parallel condition is connected. So the current will be they're not flows.
Actually, your answer is right. For an ideal voltmeter, what is the resistance? The resistance is infinite, right? The resistance is infinite. That means here V2, if it is ideal voltmeter, we are actually consider it as an ideal voltmeter. That means it has infinite resistance. Okay. When the voltmeter has infinite resistance, current won't flow through this circuit
Yes,
due to
sir.
the infinite resistance. Okay, this is the exact reason behind no current through this branch. Okay, so
Okay,
through this branch, due to the infinite resistance in V2, current won't flow. That means current will flow only through this 10 ohm resistance. For that, we have to apply Ohm's law and then we have to find out. Okay, your
Yes,
answer
sir.
is right. Very good. So then we have to apply Ohm's law. V equal to I into R. Here 10 ohm in 10 ohm into I2. That will be equal to 10 volt here, right? This battery supply. So I2 will be 1 ampere. Okay. And using this, you can calculate V2. So V2 equal to I2 into R. Okay. I2 into same potential difference you will be having. So that will be 1 into 10, that is 10 volt. Rather, these things are in parallel, so same potential difference will be there. Whatever potential difference here, it will be applicable here also. So I2 is flowing here, so I2 into 10, that is 1 into 10 equal to 10 volt. So now V2 equal to 10 volt, I2 equal to 1 ampere. Okay. Now, what is the correct option here? Can anyone tell me what is the correct option here for this question? We have completed the solution. Now, I am just asking what is the correct option here?
Sir, B option, sir.
Yes, you are right. Option B. Okay. Option B is the correct one for this problem. Do you all understand this problem?
Yes, sir.
Yes. Anyone having any doubt?
No, sir. No, sir.
Yeah. Thank you so much. Now we shall move on to our next problem.
Sir.
Yes, we are going to continue. Yes, you have any doubt?
No, sir.
Okay. Now take down the next question. In the network shown in figure, okay, each resistance is 1 ohm. The effective resistance between A and B is. So in the network shown in figure, each resistance is 1 ohm. The effective resistance between A and B is. Okay. So I will be drawing the circuit now. So this is the circuit. So you have to mark these points. This is A, okay? This is A. This node is A, and here you have 1 ohm. And here also you have 1 ohm. Here you have another 1 ohm. Here also you have 1 ohm. Here 1 ohm. And here you are having another 1 ohm. And here you are having 1 ohm. And this point is B. Okay. So this is the circuit. You have to find out the effective resistance between points A and B. Okay. Effective resistance means the total resistance between points A and B. You need to find out. For that, I will be writing the options. What are the options here? So A, it is A, it is 4 by 3 ohm. B, it is 3 by 2. C, it is 7 ohm, and D, it is 8 by 7 ohm. Okay. Now we are going to find out what is the effective resistance between points A and B. For that, what we have to do is we have to consider giving notation for currents through different branches. Okay, we need to give notation for currents through different branches. So that I am going to do now. For that, using a different color. So here let me consider that the current through this branch is I1. Okay, and here the current through this branch is I2. Okay, that means what will be the current entering inside here? Okay, through A, what will be the current entering inside? It will be I1 plus I2. Okay, then only here you will be having I1, and here you will be having I2. Okay, so then this current I1 goes here like this. I1 here you will be having I2 going like this, and at this branch you will be getting I3 here. Okay, I3 through this branch, and the remaining part of the current I2 minus I3 through this 1 ohm. Okay, I3 through this I3 actually through this 1 ohm. Okay, I3 through this 1 ohm, and since here you are having I2, right? I2 is coming towards this junction. Towards this junction, you are having I2. From this junction, I3 goes here. So remaining part I2 minus I3. So it will be going through this 1 ohm. Okay, I2 minus I3. So that's what it has been shown here. And here you are having I2 minus I3. Okay. And here you have I3. Here you have I3. And after coming over here, the same I3 flows here. And here you will be having I2, because at this junction you are having I3 towards the junction here and I2 away from the junction. Okay, I think you can understand. At this point, you can see at this junction you have I2 moving away and I3 coming towards the junction. We already know very well I2 minus I3 is coming here. Okay, the total current I2 minus I3. That means at this junction I2 is moving like this, the I3 is moving like this. Okay, so that's why you have I2 minus I3 there, and I2, and at this point you will be having here you will be having I1, and at this junction you will be having I1 plus I2. Okay, this current I1 plus I2 you will be getting here finally, and through this network you will be having I1 and I1. Okay, so here you have to mark the different arms. Okay, for your better understanding, you have to mark the different arms here. So that I am going to do now. Here, this end is actually C. Okay, according to my marking, this end is C, and this end is D, and this end is actually E. This junction is E. This point is B, as you know very well. The point C and D and E I have marked here. Okay. So here you see this arm AE. Okay, this arm. I'm showing you here AE. Okay, this arm. This arm is AE, and by symmetry you can see current through this arm AE is actually equal to EB. Okay, because why it is so? Because current through this arm CE is equal to the current in the arm ED. Okay, current in the arm ED. So here you see I3 amount of current is flowing here, same I3 amount of current is flowing here. Okay, so that's why through this arm AE current is I1, and through this arm EB the current is I1. Okay, so here the current is same through these two arms. So then what you have to find is you have to find this network, this CED. Okay, the CED, if you actually disconnect, if you disconnect the CED and AEB, if you disconnect both these things, the CED and AEB, actually both are connected at this point, right? At this point, both are connected. The CE and the ED are connected here at this point E. So when you disconnect this part of the circuit, AEB and CED, you can disconnect and you can find the resistance of the path AEB alone. Okay, resistance of this path AEB alone you can find out. So that we are going to do now. So resistance of the path AEB. Resistance of path AEB. Okay, because they are symmetrical, so we can find out the resistance along this path AEB alone. So that will be 1 plus 1 equal to 2 ohm. Okay, 1 plus 1 equal to 2 ohm. How we are getting? As I have mentioned you earlier, this part, the CED part is now disconnected from this AEB, which means you have only this part with you, AE and EB. So in between AE and EB, you are having 1 ohm and 1 ohm, both are connected in series. So the resistance of this path is 1 plus 1 equal to 2 ohm. Okay. And then resistance, now when you connect this CD now, okay, this CD. So here you have C and D. Okay. So what is the resistance of this path ACDB? Okay, now that we are going to calculate. ACDB, that we are going to calculate now. So you are having two resistances here. This 1 ohm and this 1 ohm here. Okay, so when you go from this here to here, ACDB. Okay, ACDB. So ACDB, you have to go like this. So when you go like this, you are having two resistances. This 1 ohm and this 1 ohm. Both are in series. So apart from that, what you are having? You are having this thing, this 2 ohm. Okay, this 2 ohm here in this part. This 2 ohm is actually parallel. Okay, this 2 ohm is actually in parallel with this part. Okay, with this part. So now let us calculate. So here resistance of path ACDB. Okay, resistance of path ACDB. That means A to C, C to D, D to B. So like that you have to see. So A to C, C to D, and D to B. So here you are having already a 2 ohm here, right? A 2 ohm here. The remaining resistances you have here. So that will be here you are having one resistance, that is 1 ohm. So this 1 ohm plus 2 and 1 second. So let me continue, students. So here you have this 2 ohm and this 1 ohm as parallel divided by 2 plus 1 resistance of path ACDB. So for that you are having ACDB. Okay. So you already have a 1 2 ohm here, and this is in parallel with this network. So you have to put like this 2 into 1 divided by 2 plus 1. And now, what is the resistance of this combination? Plus, actually, you have one more 1 ohm resistance in series. So here it will be 1. So this one and this 2 into 1 and one more 1 ohm. Okay. So all of these are in series here. So 1 plus 2 divided by 3 plus 1. So you have to take LCM 3 plus 2 plus 3 divided by 3. It will be a 8 by 3 ohm. 8 by 3. Now the path AEB and ACDB. Okay, the path AEB and ACDB. So this AEB and this ACDB. Okay, A, C, D and B. So as I have already told you, we consider that we have this AEB and this network are separated. And after that, what we are doing is we are calculating the resistance for this part. This AEB separately, that will be 2 ohm. And after that, this part ACDB we have done. Okay, ACDB. Okay, ACDB. So here you are having 1 ohm, and this 1 ohm is here, and this part, this 1 ohm is here. Okay, in between you have this network. Okay, this 1 ohm and this 2 ohm in parallel. So that's why I have used this 2 into 1 by 2 plus 1. I think you can understand this. Actually, we are finding the resistance of AC dB. Okay, that's what I have done here, AC dB. For that, you have this 1 ohm and this 1 ohm separately. So that 1 ohm I have written here, and this part, okay, this part is actually 1 ohm, and this 1 plus 1 2 both are in parallel. This 1 ohm and this 1 plus 1 both are in parallel. So 2 into 1 by 2 plus 1. So that will be 8 by 3. So we have done this AEB separately and the ACDB separately. Okay. Now this ACDB and this AB are in parallel. Okay. So we know that the paths ACDB and AEB are in parallel. So what you have to do? You have to apply 1 by the total resistance R is equal to 1 by 2 plus 1 by 8 divided by 3. That will be 1 by 2 plus 3 by 8. And when you take LCM, it will be 4 plus 3 by 8. That will be 7 by 8. Okay, 1 by R is equal to 7 by 8. 1 by R equal to 7 by 8. And when you take the reciprocal of that, you will be getting 8 by 7 ohm. So the correct option will be option B. Okay, the correct option will be option B. I think you understood this problem. Okay, so this is how you need to solve this problem. You have to complete this end first, this AEB first, and then this ACDB, and after that you have to consider that both these branches are in parallel. So then you have to proceed with this problem. Okay, I think this is clear to you. Okay. So now we will be discussing one more problem. I think we are having only 3 minutes. Okay. I will be giving you a few numerical problems for your test. Okay. So few numerical problems for your test. Most probably you will receive the question paper before tomorrow evening. Okay. You can solve the questions, and if you have any doubt on those questions, you can inform me, so that we will be having a discussion on those numerical problems with you in our forthcoming classes. Okay, I will be giving you some numerical problems for your test. Okay, you can solve those questions, and if you have any difficulty in solving them, you can inform me, so that we can have a discussion. And up to this point, do you have any difficulties with the concepts of current electricity? If you have any difficulties, you can ask me. On current electricity, if you have any difficulties, you can ask me. Because in our next class, we will be starting our next chapter, okay? So that's why I am asking you. Any difficulties on the concepts of current electricity? Okay, in the absence of any questions, I will be moving on to our next lesson or next chapter in my next class. Okay, and before that, I will be giving you some questions for your test. Tomorrow, you will receive the question paper. Okay, you can take your time and solve the questions. If you have any doubt, you can let me know. Okay. Now, let us keep it this much for this session. Okay, and let us continue our discussion on the. Let us start a new chapter actually. in our next class. Okay. And thank you so much for joining the session.
Okay, sir. Thank you, sir.
Thank you.
Thank you, sir.
Thank you. Thank you.